Alright, so for question 1, we have a disc in a CD player rotating at a constant rate of 300 rounds per minute. So the first thing that we realize is that this term RPM, it represents rounds per minute and it actually means frequency because it literally just means the number of revolution per minute or the number of cycles completed per minute. Just that in this case, it has been given in terms of per minute and it is more likely that we need to convert this to per second. So therefore, the frequency is simply 300 divided by 60. So that will give me 5 per second, 5 revolution completed per second. So for part A, we need to solve for the angular velocity of the disk in radian per second. And angular velocity is represented by the notation omega. Okay, some of you will call this W, but it is actually called omega. So omega, we have a formula equals to 2 pi f, or in some other cases, it may be useful for us to use 2 pi over t, but for this case, 2 pi f. So calculating, we have 2 pi multiplied by 5, giving us 10 pi radian per second. But please take note, okay, for physics, most of the time, leaving the answer in terms of pi is not acceptable. There are very specific scenario whereby it probably is acceptable to leave it in pi, but for omega, we should never try to leave it in pi, but we will calculate the 3SF number. So therefore, it should be 31.4 radian per second. So please take note, even though 10 pi seems to be a more exact answer, but for physics, okay, Cambridge may penalize if you actually put it in 10 pi. We want the answer to be in terms of 3SF, so it should be 31.4 radian per second. So moving on to part B. For part B, we need to sketch a graph to show how the centripetal acceleration of A varies with the radial distance r from the center of rotation. So for graph sketching, most of the time we may need the equation. So we should think along the line whether there is an equation that relates centripetal acceleration and radial distance r. So the more obvious equation would therefore be A equals to r omega squared. Let me rearrange this a little bit. So I rearrange it to A equals to omega square r. And why do I want to do it this way? Because it makes it more conventional. Because A, I can look at it as a y-axis, r, I can look at it as the x-axis, and therefore omega square, being a constant, should therefore be the gradient of a outward sloping straight line that passes through the origin. So essentially, to draw the graph, I have A as the y-axis, r as the x-axis, and since this is proportional, it is a proportional relationship, it is just an outward sloping straight line that passes through the origin, and taking note that the gradient here should be equals to omega squared. Okay, so lastly, let's move on to part C. Part C, I have P and Q, 2 points on the disc that are 30 mm and 50 mm respectively from the center of rotation. Calculate the linear speed for these 2 points. So take note, mm, we normally need to convert it to meter. So therefore, 30 mm is actually 30 multiplied by 10 to the power of negative 3 meter, and 50 mm is actually 50 times 10 to the power of negative 3 meter. Okay, so to calculate the linear speed means v, and we have an equation v is equals to r omega. So for part C, we simply just need to dump in the equation and then we can solve for the answer. So v is equal to r1 omega, r1 being 30 times 10 to the power of negative 3 multiplied by 10 pi. Why do I put 10 pi here? Because it is actually an intermediate working. So for intermediate working, it is actually okay for you to use a more accurate answer rather than the 3SF answer that has been rounded off in part A. Okay, so I'll use the more accurate answer, more accurate calculation 10 pi to calculate for V. So after calculating, you should get V equals to 0.942 meter per second. And then for the second one, same thing, I'll be using the equation V equals to R2 omega. R2 in this case will be 50 times 10 to the power negative 3, omega being 10 pi again. So calculating, I should get the answer 1.57 meter per second. Okay, so that's it for question 1. It's a relatively simple question. It is just mainly to help you recall the formula A equals to R omega squared as well as V equals to R omega, and then to also understand that RPM, rounds per minute or revolution per minute, actually represent frequency. So this is the typewritten solution. So if you need to copy anything, please pause the video. Otherwise, please move on to the next tutorial question.